Welcome everyone, and the last installment here. Hopefully, will offer information that people will be able to use and learn from, like I think the first three have done. So today, the focus will be on herd demographics. For those of you that are new to this presentation, I want to be sure that I offer my gratitude and my thanks to these three individuals on this list of four people here. Karen, Dr. Dave Kelton, Dr. Ewan Ferguson, and myself were part of this data mining project, and all of us were able to add something to the project in different ways, and it made for a great team because we all brought something a little different to the table. And the question was, can we leverage the data that we have in the vault? There has been value shown. I think others have seen it, and people internally here, but also our customers outside of Lactanet have encouraged us to keep going. So that's what we've done. So production and reproduction benchmarks is a pretty big part of this data mining project, but we've also dug into, I think, herd management topics to try to understand these different management topics or management questions better, to find some observations or insights on many herds across the country. So just as a review and a reminder, I guess, maybe for those of you that have been attending these in the past, remember that the data that I'm going to share today is totally observational. The variables that I'll present today, for the most part, not always, but for the most part, the data is the 50th percentile. So what that means really is we kind of rank a variable from highest to lowest, and we present the middle number. And it's kind of like the average, but not really but that's what 50th percentile means. So half the data points are going to be above the number I share with you, and half will be below the number I share with you. Today's objectives, very specifically, we want to break down herd demographics and share with some of the extra, we'll say, or further insight that we've gleaned on how herd demographics link with production and maybe reproduction. And then we'll we will share, or I'll share with you also some insights that we have on age at first calving and productivity. And we spent a little bit more time on this this past year, and it was totally based on questions and comments we received from folks that attended these meetings last winter. Herd demographics, another way of saying that maybe is longevity. And I know these things aren't totally or perfectly synonymous, but that is very closely related. And I think a general statement we can make, and I think all of us will agree with, is older cows make more milk. So wouldn't it make sense to all of us that, hey, let's milk as many as older cows as we can? And that kind of thinking, we'll say, is promoted by Lactanet, at least in some way, because or through the herd performance index, or what was previously called herd management score. And there is a score in there specifically related to longevity, certainly promoted by breed associations. So that's kind of where I would say we're kind of at right now, or currently, and where the discussion has been. So if we look at, how productivity would shake out when we look across parities and we look across regions in the country, we're talking about the top 10% of herds as ranked by 305 milk. And you can see the numbers here. I had to pick a region. I'm from Ontario, so I'll pick that. But I think all the regions have a similar type of pattern, in that when you look at first lactation, second lactation, and lactation 3+, there's a wide difference in production level, right? And if we go from lactation 1 to lactation 2, there'd be 2,300 kilos of more milk on these top 10% of Ontario herds. And if we look from lactation 2 to 3+, there's another 700 more kilos of milk by those lactation 3+ cows. So overall, when we compare the youngest animals in the herd to the oldest, there's over 3,000 kilos more milk. And, it's the exact same conversation if we look at 305 fat, right? In terms of, here are top 10% of herds by region ranked by 305 fat. if we focus on Ontario and just compare the parities, if we look at lactation 1, about just over 460 kilos of 305 fat compared to lactation 2, those lactation 2 animals have 84 kilos more. We top that up with another 29 kilos when we go from lactation 2 to lactation 3 plus. So our youngest cows in the herd to oldest cows in the herd, 113 kilos more of 305 fat yield on those mature animals. So extremely significant, big numbers here when we look at the difference. And the pattern of, the absolute numbers are different across regions, but the pattern is very similar. So wouldn't it make sense to us all that we want to milk as many of these older cows as possible? If the distribution of 305 milk would look something like this as it's related to parity, then yeah, of course we'd want to milk as many older cows as we could. Distribution of 305 milk by parity doesn't look like the previous slide. It looks like this slide. And there's lots of overlap. So the first lactation animals that are in the orangey yellow, lactation 2 is kind of tucked in behind there. They're the green bars. And then our lactation 3 plus cows are in the blue bars. But you'll see there's tremendous overlap across all of these different lactation groups. So certainly older parities do outperform the younger parities, but that is on average. Not all of the older cows do that. So if we look at, a high performing lactation 1 animal, they can certainly outperform or outproduce lower performing older cows. Okay. So if we kind of make it more of a visual versus a bunch of overlapping bars, the area that is shaded here would indicate all the animals or the distribution when lactation 1 would outperform lactation 3 plus. And that area is significant, right? So I think what I'm trying to get at is, not all the older cows are highly productive, and there are first lactation animals that are going to outperform those cows. And just to show you trends, and this is a kind of an interesting slide, really. And a lot of my slides going forward here, you'll always see that there's sort of 6 categories based on the x-axis here. And these 6 categories will indicate the percent of the herd that is lactation 3 plus. So on the left-hand side of this graph, these are the herds where there's less than 30% of the cows in lactation 3 plus on the left side. On the right-hand side, this would be the herds where there are more than 50% of the herd in lactation 3 plus. Okay, and then you got 4 categories in between those extremes. All right, but that's kind of how you can look at these graphs, and a whole bunch. Most of them are set up like this. Okay, and you'll see the trend here and this is a 4-year trend, right? So, and it's for all the Canadian herds put together here. It's not regional now, but you'll notice the trend here in the last 4 years is, the percent of the herd that's in lactation 3 plus is growing or is expanding, right? And especially in that far right category, it's expanding, significantly. It goes from about, 13, 14%, and now it's 23%. So it's increased by 10% here. And of course, you're taking cows from somewhere else. And obviously the graph isn't, it's pretty straightforward to figure out where they're coming from. And obviously then there are less herds that are younger or have those percentages of lactation 3 plus in their herd. And then there's one category here that's stayed pretty consistent over the last 4 years. But really, it is showing a very similar trend as the previous slide, which covered all of Canada. Okay. I will say that the Western herds, which is the right graph, the increase in the percent of lactation 3 plus herds, or the percent of cows in lactation 3 plus, that's more of a moderate increase compared to Canada as a whole or even as Ontario. So here we're looking, so that's more of a trend over time, what's happened. Now here, this is the distribution of herds, with percent lactation 3 plus in them for the year 2024. And we look at it by test day. So, almost 53,000 test days that go into this. And it's done by region here. So Western Canada is orange, Quebec is purple, and then Ontario and the East are the two solid lines, the light blue and black. And they kind of follow a similar trend. And then you'll notice, and this isn't a perfect convergence, I would say, but it seems that all the regions kind of converge in these two groupings: 35 to 40% of the herd in lactation 3 plus and 40 to 45% of the herd in 3 plus. Right. And all four regions are kind of close together in those areas, but they spread out quite a bit further in the other four groupings. So I looked at daily yields, and this is now more of a trend over time again. But I wanted to show you the trend that, 1 year doesn't make the story. There's not a fluke 1 year different from others. It's a very similar pattern across the last 4 years. So daily milk yields on the left, daily fat yield on the right. They almost follow identical patterns, which shouldn't surprise us. The percent lactation 3 plus in the herd groupings, 30 to 35 to 45 to 50 is kind of the same. And then when you're less than 30% of the herd in lactation 3 plus or more than 50, there's significant drop off, would say. And that's both at the daily milk yield and daily fat yield. So here we're looking at 305 milk yield, 305 fat yield. All the herds in Canada are included here, but now you get a distribution of the data for each of these variables. And we thought that it'd be useful to present this based on feedback we get about our benchmark tables. They don't just want to see an average or the 50th percentile. What do top numbers look like? What do really poor numbers look like? And that's what this slide is meant to accomplish, right? But the pattern is similar to the previous slide. That 30 to 35% lactation 3 plus in the herd, up to, for sure, to the 40 to 45% of the herd in lactation 3 plus. Those three categories for sure are similar, right? They have similar production, whether it's fat or milk or fat. It drops off a little bit on lactation, less than 30% of the herd in lactation 3 plus, drops off some greater than 50% of the herd in lactation 3 plus. And then this 45 to 50 category, it's a little bit of a wild card, certainly when you look at the poor herds, which is the dark blue line. The other point to raise about these two graphs is the top numbers, whether it's 305 milk or 305 fat, there's less variability. So I would say, maybe all the herds in all 6 categories, there are herds that are kind of outliers that can kind of manage those numbers, similarly, regardless of how many lactation 3 plus they have, because there's not a lot of drop off across all 6 categories on that purple line. The other thing that I thought I'd share too is because the Western herds seem to be on when I put this in air quotes, kind of an extreme, where they have a lot of herds in the younger categories, and then Quebec, would have lots of herds in the more mature herd kind of category, the greater than 50% lactation 3 plus. I thought it'd be interesting to look at 305 milk yields in both of those scenarios. And you can see that at the 50th percentile, or the middle line, which is green, and the low productivity numbers in the dark blue line, in both regions, the pattern is the same, really. Less than 30% of the herd lactation 3 plus, or more than, for sure, 50% of the herd with lactation 3 plus. That's where we see the bigger drop-offs. And then the 4 categories in between, a bit of variability, but they're similar. The difference becomes that top line, the purple line, which is the top 10%. And you'll notice that out west, that greater than 50% of the herd lactation 3 plus does it better. But remember, in the Western provinces, I think that's a bit related to data power. There won't be a lot of herds in that category, And I think that is part of it. But I thought I wanted to show the differences because these two regions seem to be kind of on the opposite ends of the demographic curve. The other thing that we've done the last few years when we've been looking at this kind of data is look at 305 yields for all the parities, not just the older cows, not just the herd level, but look at all the parities. And is there a difference in production across parities based on the percent lactation 3 plus in the herd categories? And on the left-hand side, we have 50th percentile, or I put in air quotes, average numbers. And then on the right-hand side, I show you top 305 fat numbers for all the categories for each of the parities. And you'll notice the trend is the same. It doesn't matter what parity you're in. There's a bit of a drop off in the youngest herds on the left-hand side of the graph, and there's a drop off on the right-hand side of the graph. And it doesn't really matter if you're in the 50th percentile or 90th percentile. I guess we could argue in the 90th percentile, those younger herds maybe will have a bit, there isn't really much of a drop off, if any, there. But certainly when we look at the herds, the numbers in the greater than 50% lactation 3 plus herds, there is even a bit of a drop off in the 90th percentile herd groupings. Okay. But the overall pattern is quite similar. And I think management plays a role in this. So you think, we're talking about lactation 3 plus in the herd. Well, how does that impact first lactation animals? That's not even what we're talking about or looking at. I think management plays a role on all facets of the herd, not just the older cows. And I think that's why we would see the patterns the way we see them here. We've also looked at pregnancy rate by these different percent lactation 3 plus in the herd categories. Maybe doesn't quite follow what we've seen in the production in the 305 yields and daily yields. And I've showed the bottom 10% of herds for preg rate in each category, the 50th percentile or the middle or the average, we'll say. And then the purple line, again, are the top 10% of herds in each of these 6 categories. And there is a drop off for these herds that are the youngest, which are on the left. There for sure is a drop off in the herds that are greater than 50% lactation 3 plus, which are the right-hand side herds on this graph. But again, we can notice the outliers or the top 10% of herds, they seem to manage their preg rate just fine, even though there's lots of mature cows on their farm. And again, I think this is attributed to management, but that's how the numbers shake out. Certainly I also need to mention and make sure you're aware, this is for Ontario and West Region herds only, because we don't have these kinds of numbers readily available for the Eastern regions. So now what we thought we do, this is what we tried this year, is it going to make a difference if we just break up all the herds in all the regions into equal 10% chunks? So instead of looking at the data in 6% lactation 3 plus categories, now we look at them in 10 categories, and you can see the categories along the bottom, and the herds are equally distributed across these. And you'll see that the pattern for daily yield is very similar, right? So there's a bit of a drop off in those herds that have the fewest lactation 3 plus cows on the left. And there's also a drop off on the right-hand side of the graph where we have greater than, it probably starts around 47.5 to 50.8. That's kind of where the drop off really starts to happen for all regions. And there's a subtle decrease. In some regions, there's a bigger decrease than others. Okay. And again, I would say the daily fat yield shows a similar pattern, and it's no surprise, right? Daily milk and daily fat yield, especially at the herd level, they normally would follow similar or the same type of trend. And then if we look at 305 yield, so instead of looking at a snapshot in time whenever test day is, this is more of a broader lactation view. And again, similar to when we have percent lactation 3 plus in the herd broken out into 6 categories, We've broken it out into 10. I would say the pattern maybe is more subtle. The line seems to be a little bit more flatter, to be honest, I would say here. But there certainly is a subtle drop off in 305 fat yield when you start getting in that 47.5% lactation 3 plus in the herd. I think that's the same for all regions here. And certainly there's a drop off when we're below 29.8% of the herd lactation 3 plus. But there's a bunch of these categories that are very similar that are in between. One of the comments that was raised by a colleague internally here is, well, maybe it's the outliers that are causing this pattern. So we got these really unique herds that are totally at the end of either side of the spectrum as ranked by percent lactation 3 plus in the herd. So if we remove those, what would we see? So we did that. And on the left-hand side of this slide, it includes all the data, milk per cow per day. On the right-hand side, this is removing the 1% of the outliers on the really young herds and the really old herds. Okay, so the first percentile and the 99th percentile have been removed. And you'll notice, without getting into the point, like the 10th of a liter or something, these graphs look almost identical. So I don't think it's the outliers that are causing some of the patterns we've been seeing, okay? And similarly with 305 fat yield, we did the same thing. All the data is on the left-hand side here, broken out by region, and you can see that via the legend, which line represents which region. And then the first percentile and the 99th percentile have been removed on the right-hand side, and you can see the graphs look pretty much identical. So I don't think it's an outlier issue that's really perpetrating or creating this kind of pattern. So finally, and I think we may have shown a graph like this in the past, but to sort of bring this back now to real life and make it more practical. So if we run this command that's in the title, you get a bit of a summary table in Dairy Comp if we were there on the upper right corner. And we see what is the average 305 milk yield for lactation 1, 2, and 3 plus. And they're color coded there for you. And then, of course, there's 305 fat yield here too. It follows the general trend. So we're going to graph every cow that makes up that summary table. Okay, so we've done that here. There's 301 dots on this report or on this graph. We're looking at 305 milk yield in this case. We could have used fat yield. So I'm not trying to advocate that this is the way to do it over fat. We had to pick one. So I picked one, right? So if we draw the line, so this is the average 305 milk based on that table in the upper right corner. Average second lactation 305 milk. Average lactation 3 plus milk. And what I want to bring to your attention is look at all the squares under the red line. All those animals are making less milk, 305 milk, than an average heifer on this farm. And we're past 50 days in milk. So most, if not all of these animals have had 2 test days at least. So we've had a couple of data points to start creating a 305 average or 305 projection if it's projected. The other thing to note below that red line is look at the colors. It's not just red. This herd, I didn't pick it just because I wanted to make sure you're aware it's blue and greens that are below the red line. I just honestly randomly picked a herd. And I think this would be a typical herd. They make pretty good milk, 12,400 kilos. So that'd be in the top 25% of herds, I think, right? So it's a well-managed, good milk herd. But you can see there's blues and greens below that red line. Not all the mature cow, not all the older cows on this farm at least can make good milk or where we'd expect them to make milk. So then the question is, why are they still there if a first lactation animal can make more? And there's lots of reasons for this. And for this particular farm, the reasons why they're there, I bet you the majority of cases, there are good reasons for it. She's an excellent cow. We get lots of very good daughters off of her. She gets pregnant on the first service at 63 days in milk every lactation. You can rattle them off, and for the producers on the call here, you will have those similar type of reasons. But there is a price for that, at least from a production standpoint. So I think, just a couple of quick take home messages. I would say, the success of longevity in a herd is going to depend on management. I think we all have to realize that not all older cows perform well or perform better than maybe younger ones do. And we need to, we can't be afraid to just keep the older cows that perform. It's okay to call the older cows that are not performing, right? And knowing when it's time to call cows in general, whether it's, I guess, first lactation or older cows, that takes management, that takes judgment, and we can't be afraid to make some of those calls, right? When we look at Canadian regional data, I think we do see productivity decline when herds are too young and when they're too old. So I'm not trying to say that we really got to hammer on the old cow side. When our herds are too young, there's also a price to be paid, right? And I think our data has been showing you that. And there's certainly, in most herds, there is a reduction in repro as well when we're seeing on our younger herds and on our more mature herds. That kind of covers off the piece on demographics and longevity, we'll call it, I guess. I think this kind of dovetailed really nicely into talking about dairy replacements. And as it relates to productivity, it's kind of a focus on lactation 1 animals on the farm. But I think before they get to lactation 1, they're baby calves and they're heifers, and raising those animals is a significant cost to the dairy, right? And it can be up to 20% of the cost for the dairy is related to raising heifers. And so I think it's extremely important and in the dairy's interest to want to grow these heifers and raise them efficiently and reduce the non-productive stage. And I think one of the goals of managing replacements is we want to do it in a way so that they can outperform their dams once they get to the milking herd. But the success and the ability to reach this kind of goal that's in the second bullet requires more than just saying, hey, let's get heifers milking by 22, 23, 24 months of age, and we're going to be ready to roll on this, right? It's more than just that. And if that is how you're managing today, or that's how your clients are managing their replacements today, I think that there's an opportunity to discuss further, because I think if raising calves and growing heifers isn't done very well, trying to just pick an age and let's get them into the milking string isn't going to be very successful. Okay, and I think all of us have witnessed this in a herd or two. Just to give you a kind of a what is the trend in terms of distribution of age at when first lactation animals are freshening. This is over a 4-year period. It's all heifers in Canada. We're somewhere in that 100,000 to 120,000 first lactation animals each year that go into this. Okay. And you'll notice the pattern is roughly the same. There's a little bit of fluctuation with the bars, but overall the pattern is the same. I'm focusing on the 20 to 28 month age range here, but we have heifers calving out at 18 months in Canada, and we have heifers calving out at 40 months in Canada. But if we want to look at the trend of 305 milk yield based on age at first calving, and the shaded part here is focusing on where the majority of heifers freshen, there's not a huge difference year over year. That orange line, which is the year 2022, it kind of sticks out a little wee bit in the shaded area, but look at the scale on the y-axis there, it's not a huge difference. So we'll blame that on COVID, I guess. And then once you get out to the higher age in months, calving out, like the higher age at first calving months on the right-hand side, then we start getting into a data power issue, and, weird data and abnormal data is really going to skew that graph on that end. The other thing to note, just as a quick before we move on here, is look at the 18-month fresh age at first calving group. And granted, there's not a lot of animals there, but it's pretty consistent across all 4 years what happens when heifers are calving out at that age, right? So I think there's also a comment to be made that heifers can be too young as well. So if we look at 2024 data now, and this is, just over 103,000 completed lactation 1 records in Canada, there's a very subtle decrease in 305 milk yield as we get, we'll say, past 26, 27 months. And certainly there is a decrease when we look at the gray line, which is the 50th percentile number, and the blue line, which is the 10th percentile number. So those 10th percentile, numbers are really low producing first lactation animals. And there's an even bigger decline as heifers get older there. But then you see the green line and the outliers from a good production or a high production standpoint. It seems like they hold on longer, and they're not maybe they're not observed to have as big a decrease until we get to about, 30 months of age almost. Not as variable on that top line. If we look at 305 milk yield by age at first calving along the bottom, but now we look at it by region, and I highlight, where the majority of heifers freshen. And, the pattern is roughly the same. The orange bar, or the yellow bar, I should say, which are eastern herds, there seems to be a bit of a drop off going from 22 to 26 months. The other regions, it is about as flat as you can be in terms of consistency. There certainly is a bit of a range in terms of 305 milk across regions. I think we've seen that in our benchmark tables before, so that shouldn't be a surprise to us. But again, look at the scale on the y-axis. It's not a huge numbers, but it's significant enough in terms of the difference between regions. But the pattern is really the same if we look within region and age at first calving. When we look at peak milk, and now the next two slides are things that were asked about last winter, was peak milk any different based on the age at when the heifer freshened? And again, I highlight the area when the majority of heifers freshen, and it doesn't make a huge difference, if any difference, on peak milks, at least between 22 and 26 months of age. Certainly the heifers that calve out on the really young side, on the left-hand side of the graph, there is a big difference, certainly. And as heifers get older when they calve out for the first time, there is also a drop off in peak milks. But in the, where the majority of the heifers calve out at, there's not a huge difference in peaks. Persistency kind of tells a similar story. Certainly it tells the same story when we look at heifers calving out between 22 and 26 months of age. Doesn't really matter what region we're in, the persistency is the same. There is some differences across or between regions as to what the persistency level is. It ranges between about 83% in the Quebec heifers, and it ranges about 88 or 89% for the West heifers. But the pattern on how it changes by age at first calving is no different. The one thing that is different compared to peak, though, is there doesn't seem to be that drop off on the the heifers that calve out on really young ages, and the drop off, to me, is less for the older ages as well. So the persistency is pretty, I would say relatively consistent regardless of age at first calving. And that would be similar across regions. The other thing that we kind of tried to take some stabs at this over the last 3 years. But what we're doing here is we're looking at what was the age at first calving for animals, but what was their lactation 2 and lactation 3 305 milk. So this isn't lactation 1 305 milk now, but it is lactation 1 age at calving. And, we looked at lactation 3 records that were completed in Canada, and there was almost 18,000 records like that. So then we could look backwards to see what was age at first calving, what was, second lactation 305 milk and third lactation 305 milk. And you can see when heifers calved out older in first lactation, that doesn't translate to more milk later, because I think that's some of the argument. If you grow them longer, you might take a bit of a hit in first lactation, but you're going to make it all back when they're older because they're grown better, right? And that isn't what our data is showing. In that spot where heifers normally freshen, and even on the earlier side, when they freshen on the earlier side in lactation 1, they seem to do the best in future lactations as well. So the last few slides here, just to put some practicality to this, and for those of you that are using Dairy Comp, and I think the majority of people on the call will be, how can we look at first lactation performance? Some of these tools or reports and graphs that I'll show here, I think a lot of you will know these already. The command is in the title here. But here, the nice part about looking at the data in this scatter graph form is you can see the distribution, not only at age at calving for first lactation, but also the production for our first lactation animals. So I find this a really good visual. And you can see there is some variability for this herd. If you change the command in the title and replace the word graph with sum, you will get the table that's in blue embedded in the graph. Okay. So it's almost the identical command. You just got to use the word sum, S-U-M, instead of graph. And you can see when you look at averages, it doesn't give you the same sort of picture. But certainly calving heifers out, later, we got lower 305 milks, but just look at the count for 2-1, 2-2, 2-4. The count of animals that make up those averages is low. So we just got to be cautious when we interpret. But if, it would appear that, waiting to calve out heifers on this farm in the 5 cases, I guess 4 of the cases, it probably doesn't really help us. The 1 case, I suppose it does. But anyway, that's the kind of ways we can look at the data from a graph standpoint, a number standpoint. Here we can get more of a time trend instead of an age trend. So we're looking at cohorts of first lactation animals fresh in month by month fresh. So for example, that top row, 3 lactation 1 animals freshened in October 2024. That's 5% of the total. And on average, those 3 animals calved out at 701 days of age, and that's their 305 milk is 10,517. So again, looking at cohorts by month fresh, if it's a small herd, this might not be very useful. I'm not sure. I would say not. Certainly caution needs to be used because there's not many numbers that are making up these averages for sure. And you could graph it too. But this is the way I decided to provide an example of presenting back the data. For many of you, you probably have to create an item called age F1 or something like that, age at fresh 1 or calving or lactation 1. And it's an item type 49 and it's fresh date minus birth date. That's how you get the number. So that sometimes can be helpful. Is there a way to monitor lactation 2 production based on what the animal did in lactation 1? So we can break that kind of data out into quartiles, and that's what I've done here. You need to create an item 305L1 or 305 milk lactation 1. It's an item type 93. You get an option to choose 305ME or total milk. I'm saying choose 305ME. In Canadian files, that really means 305 milk, not mature equivalent milk. And then you can, as long as you go by 305L1, which is in the command in the title, it'll rank the second lactation animals by how they did in lactation 1. And then you can look at, well, how are they doing in lactation 2? And that's what 305ME is doing for us. ME fat that's what that is doing for us. And, it follows the general trend. If they were good producers in lactation 1, they seem to be good producers in lactation 2, right? And you can see that this herd's broken equally into 4 quadrants. There's 20 animals in each group except the one having 19, right? So that might be another way to look at, one lactation to the next. And then finally, I don't know, I think it's just by coincidence, but I've had a number of people ask me here recently, how does actual production compare to the genetic merit of the animal? And Dairy Comp, I think you can do that in easy ways too, as long as you have the genetic data points that you want to do your comparison to do your comparison by. In this case, I'm comparing mature equivalent 305 fat yield with genetic fat yield or our genomic fat yield if it's a genetics genomic tested animals. And you can see, there is a strong trend that if the animal has high genetic fat yield, which is along the x-axis, they would also have high 305 mature equivalent fat. So I would say there's a strong correlation, at least for this farm, with genetics and actual production. And you can do that fairly easily with a command like in the title there. If you're in Dairy Comp, you can click on the squares and you can see the individual animals if you have to. But you'll see the command in the top. Just as a note, and then we'll wrap up here. The R switch, the /BR. The B, make sure we look at animals even if they've left the herd. So active and inactive animals. And then the R puts that regression line on the graph. Like the blue line you see, that's what the R switch does for us. Okay. So some quick take-home points. 22 to 26 months of age continues to be where the majority of heifers enter the milking string across the country. It's not all the heifers, of course, but that's where a big chunk of them are calving out. And that trend hasn't changed a whole lot over the last number of years. 305 milks trend lower as age at first calving increases. And I probably should also add, it also trends lower young age at first calving months. So I should probably have added that in there. There certainly is a subtle decrease in peak milks as age in first calving increases in the 22 to 26 month period, but there's more of a decrease on either side of that 22 to 26 month range. Not a huge change in persistency with age at first calving. The numbers are a little different. There is some difference across region in terms of what is the persistency, but as it relates to age at first calving, there's not a lot of change. And Dairy Comp has different tools that can help you assess first lactation animal performance. So, some just quick final thoughts that kind of wraps up the information I wanted to share, but just final thoughts on the webinar series and the data mining project. The whole goal of this was to add value to the information collected by Lactanet on test day and report back to customers. That was a big goal of ours. So hopefully that's been reached. Hopefully some of or all of you can make some use out of the detailed benchmarks that were presented and then are available on the Lactanet website. It's regional, it's for the country, it's by parity, it's for herd. So there's a lot of good information there. And then hopefully the insights and observations, I'm not sure, I'd like to think it's practical and it at least gives you some food for thought on how you might manage your herd going forward. And even if it makes you question how you manage today, I think it served the purpose, right? And I think some of the insights or observations that we've come up with through the data mining project kind of maybe don't always follow exactly what we think or what we perceive would be happening or should be happening. And so hopefully that helps maybe put a more shiny light on some of these management topics. Please don't hesitate to reach out if you have questions or if you have, strong feelings on ideas for new data mining. We're starting to gear up for doing it again this year. So always very willing to listen and hear new ideas on what we can do better or what we can do more. So with that, I'm going to stop. I'll pass it back over to you, Jeff.
We do have a question, Jeremy, though, for you.
Sure.
You showed the graph with 305 milk at and age at first calving for the heifers, but have you looked at the same graph for second lactation cows? A lot of people talk about the sophomore slump in second lactation cows who calve at a young age. Just wonder if you had any data to support that theory.
So I'm just going to use my slides for a second. So I'm assuming this graph isn't exactly what this person is asking about. I think what they're wanting to see on the x-axis is the age at second calving, I wonder. So if I've interpreted the question correctly, then the answer is unfortunately we don't have that data right now, but that's a great idea for us to explore for this upcoming year. And I'll make sure I have a bit of a running list, and we can certainly look at that. But this would be as close as I could come to talking about anything to do with the question asked, but I don't think that's exactly what was wanted. So, um, but that's, I think there's an opportunity there for some more digging this upcoming year.
Good. If there's anybody else has any more questions, I'll give you another couple seconds here to ask them. But I'd like to take the time to thank you, Jeremy, for what you've done and the work you've put in. Your passion definitely comes through for data, and you and Ferguson's on the call here as well. And Ewan was a big part of this with Jeremy. The two of them had lots of thoughtful conversations trying to come up with this stuff, and I think we're all benefiting from it. And your passion has definitely come through. So I like to say I appreciate everything you've done, Jeremy. I know the hours you put into it, and it definitely shows. So with that, I see that there's no more questions. So thanks, everybody.